Welcome to the third offline lab lecture of Service Systems Design and Planning course. In this lecture, we will apply analytic hierarchy process on a computer purchase decision-making problem. In this problem, we have a company that wants to purchase computers, and they identified three criteria: cost, user-friendliness, and software availability. They have already provided the pairwise comparison matrix for these objectives, as you see on the slide. The company identified three computer models, and the performances of these computers for each objective are provided in these matrices. The data is available here. It is already shared in Uzak Etu. And next, we will apply analytic hierarchy process in order to suggest a computer for the company. I have already prepared a template for analytic hierarchy process. As you know, we have a two-step weight or score calculation process, and also we have a four-step consistency check for these pairwise comparison matrices. Okay, let's start with objective comparison matrix. Let me open a new sheet and give name as objective. Okay, I will copy all these to the new sheet, and then I will take this objective comparison matrix to this sheet. In step 0, we use two simple rules for consistency check. First of all the entries in the diagonal should be 1. Yes, it is satisfied for this matrix. And also, if Aij is k, then Aj should be 1 over k. This is also satisfied, as you see here. In step 1, we normalize each column and obtain a norm. For a norm, we should divide each entry by the sum of all the entries in this column, right? I want to reuse this formulation, so I should put dollars to these parts so that we can reuse this formulation for other cells as well. As you see, it correctly computes the normalized entries for each cell. Okay, this is normalized pairwise comparison matrix. Then in step 2, we estimate the weight vector as the average of entries in row I of A norm. Okay, so we take the average of the entries in each row in order to find the weight of the corresponding objectives. After finding weight vector, we need to apply four-step consistency check. In the first step, we compute A times W transpose. Let me first identify the size of this vector, A times W transpose vector.
A is a 3 by 3 matrix and W transpose is a 3 by 1 matrix. So the result should be a 3 by 1 matrix.
Suppose that these cells correspond to this A times W transpose vector. Then I will use M mult or D sharp function of Excel. I will multiply this matrix with weight transpose vector. Okay. After that, I should
press
Ctrl Shift Enter
simultaneously.
This is A times W transpose vector. Next, let's compute step 2 result. How do we compute it? We should divide each entry in this vector by the corresponding entry in the weight vector. Let's perform this. Similarly, I can reuse this formula for the other cells, and after that, I should, of course, check whether it works properly. And then, as you see here, I should multiply this summation, the sum of these cells, by 1 over n. It is actually taking the average of these entries. Okay. So this is step 2 result. I will use this step 2 result when I compute consistency index in step 3. Okay, let's compute it. We should subtract n from, n is 3 here because we have 3 objectives from this step 2 result and divide it by n minus 1. Okay, so I obtain this value as consistency index. Next, let's find random index, which is already provided on a table. Since we have 3 objectives, our random index is 0.58. Then I should divide Ci by Ri. If the result is less than 0.1, then we say that it is consistent. Okay, as it is less than 0.1, we say that the pairwise comparison matrix provided for the objectives is consistent, so we can use these weights. Let me highlight them. We can use these weights for the overall score calculation. Next, I will perform score calculation for each objective. Let's start with user-friendliness objective. Again, I will use my template in order to calculate the scores of each computer for this objective. Let's take the pairwise comparison matrix from our data sheet. This is actually A. First, we should use 2 simple rules for consistency check. As you see, diagonal cells are all 1, and if Aij is k, then Aj is also 1 over k, and so step 0 is satisfied. Next, we can continue with step 1, where we get the normalized matrix. We should divide each entry by the sum of entries in the corresponding column. And as we want to reuse this formula, we need to insert dollars to the appropriate places. Okay, let me check whether the formulation is correct. Okay, it is correct. In the next step, in order for score calculation, we take the average of each row. Okay, so we have obtained the scores for user friendliness for all computers. Next, we should apply 4-step consistency check. In the first step, we should compute A times W transpose. How do we compute it? We know that it is a 3-by-1 matrix. We should select these cells, and then we should use M-mult or the sharp formula of Excel in order to calculate this matrix.
I press Ctrl-Shift-Enter simultaneously.
In order to compute the values for all entries, and then in the second step, we should divide the entry, each entry of this vector by the corresponding entry in the weight vector, and then we should take the average of these values This provides us step 2 result, and then we will use this step 2 result in order to compute consistency index. N is again 3, since we have 3 alternatives, 3 computers to be considered, and we should divide it by N minus 1. This is the consistency index. If we look at the table, we will find the random index as 0.58, as we have 3 alternatives. Next, we will compute Ci over Ri. Is it less than 0.1? No, it is not less than 0.1. So let's return back to our presentation and
talk about what we can do
in order to make this matrix consistent. As you see here, our user-friendliness matrix is not consistent. We have already performed the check for 2 simple rules. These are satisfied, but we have something strange here. What is that? In columns 1 and 3, we see that computer 2 is the most friendly one, followed by computer 3 and computer 1. However, column 2 orders the computers as computer 2, computer 1, and computer 3. We should have a consistent ordering for all columns or all rows for all computers. Suppose that we ask the decision maker to rethink this comparison matrix, and let's assume that the decision maker changed these highlighted cells as follows. Again, we satisfy the second simple rule. Let's make this change here. Change this cell by 0.5, and this should be 1 over k by simple rule 2, and all computations are automatically performed by the Excel, as you see here. So we get a ratio which is less than 0.1. So after this change, the pairwise comparison matrix becomes consistent for user friendliness. Next, let's continue with the next objective, software availability. Again, I will copy the template to our new sheet. Right now, our A matrix is this one. Let's take it to our sheet. And if we check our 2 simple rules, the first one is already satisfied. As you see here, the second one is not satisfied for these cells. So we should ask the decision maker to fix it. And suppose that it changed this cell that has a value of 3 to 2. Okay, so that the second rule is satisfied, 1 over k. Next, we can apply step 1. In step 1, we normalize this matrix. We should divide each entry by the sum of entries in the corresponding column. And since we want to use this formulation for all entries, we put dollars to the appropriate places. Okay, let me check whether the calculation is properly done. Okay, next we will compute the score vector for software availability. How do we compute it? We estimate it as the average of entries in the corresponding column. Okay. Okay, we have this score vector, but we should be sure that this matrix is consistent, so we should apply first step consistency check. We should select a 3 by 1 matrix, and we should apply our D sharp, or in English, mult function. Let's multiply A by the score vector. After that, we should simultaneously press Ctrl Shift Enter. Okay. Next, we should perform step 2. In this step, we divide each entry by the corresponding entry in the score vector. Okay, we get this. And then we should take the average of all entries in the resulting vector. This is step 2 result, and we will use it in order to compute consistency index. Since we have 3 alternatives, n is 3, so consistency index is calculated like this. Random index is this one. And so we can calculate the ratio of Ci to Ri, and it is less than 0.1. So we say that the resulting matrix after this change, of course, is consistent. So we can use this vector as the score vector for software availability. Let's perform this for this vector as well. Okay, the last objective is cost objective. Let's quickly perform the same steps for cost objective. Again, we copy the template sheet to our new sheet, and let's take the corresponding pairwise comparison matrix. Okay. First, we should use 2 simple rules. The first rule is satisfied, as you see. The second rule is also satisfied, as you see. So we can continue with the first step. In the first step, we should normalize the matrix. Okay, how do we normalize it? We divide each entry by the sum of entries in the corresponding column. In order to reuse the formulation, we need to put dollars to the appropriate places. And then we compute all the entries. Don't forget to check whether the formulation works properly. Okay, next, in the second step, we should take the average of each row. Okay, so we get this score vector for cost. However, before using it, we should be sure that this matrix is consistent. How do we perform consistency check? In the first step, we compute A times W transpose vector. We should select all these cells, and we should use D sharp in Turkish or mult in English function of Excel. Let's multiply A vector, A matrix by score vector. We should press Ctrl Shift Enter simultaneously and obtain the result. And in step 2, we should divide each entry by the corresponding entry in the score vector. And then we should take the average of all these entries in order to obtain the step 2 result. We will use this result in order to compute consistency index. N is 3 since we have 3 alternatives. And we get this consistency index. Since N is 3, random index is this one. And if we compute the ratio of Ci to Ri, we get this value which is less than 0.1. So we say that this pairwise comparison matrix for computers for the cost objective is consistent. So we can use this score vector for the cost objective. Okay, what should we do next? We need to make a selection. Let's use another sheet to calculate the overall scores of all alternatives. We have these objectives, and the weights of objectives are calculated as these are objectives and these are their weights. Next, for each objective, we have scores calculated for all computers, C1, C2, and C3. Okay, let's take the scores. User friendliness scores are as follows. And next, let's take the scores of computers for cost objective. And finally, for the software availability objective. These are scores. Next, we will compute an overall score for each computer. Okay. Here we should be careful. For cost, the company prefers the computers with a lower score, since lower price is better. However, for user friendliness and software availability, the company should prefer computers with higher scores. How can we use this insight? When we compute the overall score, we should multiply the weight of cost by 1 minus score of the corresponding cost. And for user friendliness objective, we should multiply the weight by the score directly. And for software availability, again, we should multiply the weight by the score directly. Okay, similarly, for computer 2, we should multiply the weight of cost by 1 minus score for that computer, and for the other objectives, we should multiply the scores by weights directly. Okay, again, for computer 3, we multiply cost weight by 1 minus score of that computer for cost objective. However, for the remaining objective, we should multiply the scores by the weights directly. This is one approach that can be used in the cases where we have different objectives having different positive or negative effects on the overall score. Another alternative is using 1 over score instead of 1 minus score for the objectives that have negative effect on the overall score. Let me apply this as well. Instead of this 1 minus score, we will use 1 over score. Similarly, let me copy this formula and change 1 minus score by 1 over score. And for this third computer as well, let's copy the formulation and change 1 minus score by 1 over score. This is overall score by alternative application 1. This is the overall score by alternative application 2. How does alternative 1 orders the computers? Computer 3 is better than computer 2 and it is better than computer 1. Similarly, alternative 2 orders the computers as computer 3, computer 2, computer 1. So, after applying analytic hierarchy process, we can suggest computer 3 to be selected for this purchase.